So good evening, welcome to Sakalvidya YouTube channel. Okay, now actually we have been discussing the partial fractions for diploma basic engineering mathematics, and it will be useful for even intermediate examination also, intermediate different board examinations in CRT and as well as state boards. So once again I welcome you all. Akshay Reddy, I welcome. So far we have discussed actually type 2 methods, that is type 1, type 2. So now today we are going to discuss type 3. Type 3. So this is type 3 model, and followed by the few examples today. So we shall discuss type 3. Type 3 means when the denominator contains, so when the denominator, let us say g of x, when the denominator g of x, good evening Kaif, g of x contains irreducible, that means further it cannot be split, irreducible quadratic factor, of the form ax square plus bx plus c, where a does not equal to 0. Somant Datta, welcome. Kishore, Tattu Sharma, welcome. Then there exists a partial fraction of the form ax plus b, linear polynomial, upon ax square plus bx plus c. That means for each irreducible quadratic factor ax square plus bx plus c, then there exists a partial fraction of the form ax plus b by ax square plus bx plus c. झारखंड का सिलेबस आपका पास है तो मेरा को भेज दे, वो भी मैं कवर करता हूँ. सोमन दत्ता, मेरा ईमेल आईडी दे तुम इधर. ईमेल आईडी है kv small k small b 9641 @gmail.com. आप मेल को भेज करो, मैं देखता हूँ. ठीक है. So let me repeat once again type 3. This is a partial fraction chapter. This is okay. Thank you, Somnath. When the denominator g of x contains irreducible quadratic factor of the form ax square plus bx plus c, where a does not equal to 0, then there exists a partial fraction of the form ax plus b upon ax square plus bx plus c, where a and b are constants. Need to be evaluated. Constants. So we shall discuss some examples. So first example, sum 2x plus 3 by upon x plus 1 into x square plus 1. So how could you find out the partial fractions of this one? See, if you observe, actually this is in the form of f of x by g of x. Just look the g of x itself only. G of x, that is called denominator. See, this denominator contains x plus 1. This is called non-repeated linear factor, and x square plus 1. X square plus 1 cannot be split further. So thank you, electronics for you. After a long time, many thanks, Vasant. Okay, how are you? Fine. So this x square plus 1 is called as irreducible quadratic factor. So this is non-repeated linear factor. Linear factor. So that means if you want to find out the partial fractions of this one, if you are asked to resolve partial fractions of this model, for x plus 1 there exists one partial fraction. For x square plus 1 there exists another partial fraction. Total two partial fractions need to be evaluated. So that means general we can write like this: 2x plus 3 upon x plus 1 times x square plus 1 is equal to a upon x plus 1 for x plus 1 factor, plus next we write bx plus c. Already a constant is there. You can take bx plus c upon x square plus 1. If you are able to find this a, b and c values, so then the partial fractions can be evaluated. Easily we can find out the partial fractions. So as to find out partial fractions of this one, so first we need to write this step. After that we need to find out a value, b value, c value. After substituting a value, b value, c value in this one, you get the partial fractions. So now let us proceed for the problem section. So now let us move to the problem section. Okay, now so this is the first problem. So just see, this is the question. Resolve 2x plus 1 by x square minus 1 multiplied by x square plus 1 into partial fractions. This is the question. Please all of you note down. Look at the screen also. Okay, let us solve this question now. Now the solution. So let this 2x plus 1 upon x minus 1 multiplied by x square plus 1. See, so clarity, yes, it will come clarity, don't worry. So equals to, for x minus 1 there exists a partial fraction a upon x minus 1, plus for x square plus 1 there exists a partial fraction of the form bx plus c upon x square plus 1. Okay, this is the first step, we need to write it. So now the 2x plus 1 upon x minus 1 times x square plus 1 equals to x minus 1 multiplied by x square plus 1. If x minus 1 multiplied by x square plus 1, x minus 1 gets cancelled. Here we get a times x square plus 1 plus x square plus 1 gets cancelled. We get bx plus c times x minus 1. Here, so one thing you can write, this x minus 1 into x square plus 1, x minus 1 into x square plus 1 gets cancelled. Am I audible to you? It's clear. My voice is clear. Yes or no? Right. So now we get like this: a times x square plus 1. Thank you, Gafur. X square plus 1 plus bx plus c of x minus 1 equals to 2x plus 1 we can write. So first let us proceed for the substitution. Since we have x minus 1 linear factor, so now here let us suppress x minus 1 factor. X minus 1 is equated to 0, so we get x is equal to 1. Now put x is equal to 1. If you put x is equal to 1 on both sides, what do you get now? This x minus 1 factor going to be suppressed. So a times 1 square plus 1 plus bx plus c times x minus 1 is 0. Am I correct? Now we get 2 times 1 equals to, 2 times 1 plus 1. So let us simplify. So that implies a times 1 square is 1 plus 1, 2 plus 0 equal to 2 plus 1. So 2a equals to 3. So therefore we have a equals to 3 upon 2. A value has been obtained. We know the a value. I think it's clear. It's clear. Now let us move to find the b and c values. That will be evaluated like this. I will explain. So right, see. Now we need to find out here b and c values. How to find out? Let me explain. Okay. Okay. Now just this one, simplify it. You get like this. So we have ax square plus a plus bx into x, bx square, bx into minus 1 minus bx, c into x plus cx, c into minus 1 minus c equals to 2x plus 1. Okay. So now from these two take x square common. So from these two we can take x common. These are constants. These two are constants. We can separate it. So that means we can write like this. If you take from ax square, bx square, x square common, you get like this. A plus b times x square you can write. Minus bx plus cx, x common, we have c minus b times x. Here a minus c plus a minus c is the constant, equals to 2x plus 1. So comparing coefficient of x square on both sides. Comparing x square on both sides. Let us see what do we get. Comparing x square on both sides means, you see, x square coefficient is a plus b. Here x square coefficient is absent. Absent means 0. So that means we are going to get here, that is, we need to write like this. That is a plus b equals to 0. Since a plus b is equal to 0, we get b equals to negative a. But a is 3 by 2. Substitute here. So we get this value is minus 3 by 2. So that means b value has been obtained. That value is minus 3 upon 2. Minus 3 upon 2. This is the b value. So now we need to find out here already a value is known, b value is known, c value we need to find out. So now here comparing the constant terms, a minus c is compared to 1. We'll get it now. So now let us find out now. Okay, now so comparing constant terms on both sides. So comparing constant terms. So what do you get now here? So that is, here constant term is a minus c, here 1. A minus c equals to 1. But we need c value. That implies c equals to a minus 1. A is already, we know that a value is 3 by 2. So we can write c equals to 3 by 2 minus 1. 2 is the LCM. 3 minus 2. So 1 upon 2. That means C value equals to 1 upon 2. So let me check. Now here you check it now. This is the A value. Okay. Clear? This is A value. So now this is B value. This is C value. This A, B, C we need to substitute here. So that means partial fractions we get like this. So now we can write like this. So therefore, so we'll get like this, no problem. Wait for a while. And therefore partial fractions, therefore 2x plus 1 upon x minus 1 times x square plus 1 equals to, we can write a means 3 by 2 upon x minus 1 plus another partial fraction is bx plus c by x square plus 1. So go for the here b value. See, b value is minus 3 by 2, c value is 1 by 2. Minus 3 by 2, 1 by 2. So minus 3 by 2, 1 by 2. So we can write minus 3 by 2 times x plus 1 upon 2 upon x square plus 1. So now we need to simplify this one. So we need to simplify this one to write the partial fractions. So how could you simplify? You see, this can be written 3 upon 2 times x minus 1 plus this can be written, see, 2 is the LCM. This is minus 3x plus 1 or 1 minus 3x also upon 2 by x square plus 1. This we can write 1 minus 3x upon 2 times x square plus 1. Hence the partial fractions have been obtained. Thank you, Syed, Saim, Tarun Raja. Thank you. So okay, I will show you the once again. See the method. All of you observe. See once again. If you are asked to find out resolve 2x plus 1 by x minus 1 into x square plus 1 into partial fractions. So let 2x plus 1 by x minus 1 into x square plus 1 is equal to a upon x minus 1 plus bx plus c by x square plus 1. Now 2x plus 1 by x minus 1 into x square plus 1 equals to a into x square plus 1 plus bx plus c into x minus 1. This gets cancelled. We get a times x square plus 1 plus bx plus c into x minus 1 is equal to x plus 1. X minus 1 factor has been suppressed, so x minus 1 equals to 0, x is equal to 1. Substituting x is equal to 1, first we get a is equal to 3 by 2. So now we need to simplify and separate x square coefficient constant. Comparing x square coefficient on both sides, a plus b is equal to 0. We need b value. B is equal to minus a. Already a is 3 by 2. So this is minus 3 by 2. So b is minus 3 by 2. So now comparing constant term, a minus c is equal to 1 and c is equal to a minus 1. A is already 3 by 2. Substituting here 3 by 2 minus 1. 2 LCM, 3 minus 2. So by 2. 1 by 2, c is 1 by 2. We know the a, b, c values. Next we need to substitute here. We get a by x minus 1, 3 by 2 x minus 1 plus bx plus c. b is minus 3 by 2 plus 1 by 2. Simplification, this becomes minus 3x plus 1 or 1 minus 3x by 2 by x square plus 1. That we can write 1 minus 3x by 2 times x square plus 1. So these are the partial fractions. Okay, thank you. So let us move to the next. Second question. Let us move to second question. Okay. Right. So this is the second question. So just note down the second question now, all of you. Resolve x square plus 1 upon, this is x square plus 1 upon x minus 2 into x square plus 4 into partial fractions. So let us do first. What shall we do? Solution. See, consider, or let us say no problem. So let this x square plus 1 upon x minus 2 multiplied by x square plus 4 equals to. So we get two partial fractions that we need to write it. First partial fraction is of the form a upon x minus 2. Okay, plus for x square plus 4 is the irreducible quadratic factor. For that one we get bx plus c upon x square plus 4. Say equation 1 this is. You might have understood this one. So next we need to simplify this one. X square plus 1 upon x minus 2 times x square plus 4 equals to, here LCM is x minus 2 times into x square plus 4. So now x minus 2 into x square plus 4 divided by x minus 2, then x minus 2 we gets cancelled. We get a times x square plus 4 plus bx plus c multiplied by, we get x minus 2. So now this x minus 2 into x square plus 4, x minus 2 into x square plus 4 cancel. So now we have a times x square plus 4 plus bx plus c times x minus 2 equated to x square plus 1. Now substitution. What is the substitution? Instead of x minus 2, put 0. You get x is equal to. So put x is equal to 2. Means x minus 2 is equal to 0. That implies we get like this, a times 2 square 4 plus 4 plus bx plus c times x minus 2 is being 0 equal to, again 2 square is 4 plus 1. Am I correct? So this can be written as 4 plus 4, 8. 8a plus 0 bx plus c times 0, 0, 5. 8a equals to 5. Therefore, a value equal to, we have 5 upon 8. 5 upon 8. So that means a value has been obtained. But we need to find out bx plus c. So let us proceed this method now. So now we need to simplify this one. We need to simplify this one. We need to simplify this one. This expression we need to simplify. Concentrate on this one. So how could we simplify? Let us simplify it now. So 1 minute. Just I move like this. Okay. So now this can be written like this: ax square, just open the brackets, that's all, plus 4a plus see bx into x, bx square, bx into minus 2 bx, minus 2bx, okay, minus 2bx plus cx minus 2c equals to x square plus 1. Okay, clear? Right. So next what we need to do means ax square and bx square. Next we have here from this minus 2bx and cx, you need to take x common, and 4a we have minus 2c. Right, Luli Shiroseki, 20 random cards placed. That we need to think of infinite number of trials. Infinite number of trials. You need to do that problem using counter example method. So for example, n trials, and we need to prove that it's a finite trials. It is not possible. Right. So now we get here x square common, a plus b times x square, plus here x common, we have c minus 2b times x, plus 4a minus 2c equals to x square plus 1. Right now, comparing coefficient of x square, coefficient of x square on both sides. Comparing coefficient of x square on both sides, we get a plus b equals to coefficient of x square is 1. So that is a plus b equals to 1. Already a value is known, b we need to find out. That implies b equals to 1 minus a. Since a is 5 upon 8, 1 minus 5 upon 8. 8 is the LCM. 8 1 ja 8, 8 minus 5. It's a difference of the fractions only. 3 upon 8. So b value equals to 3 upon 8. So now we need to evaluate the c value. How to evaluate the c value? Just comparing the constant. This 4a minus 2c is equal to 1. Or even x coefficient also we can find out c. Here x coefficient is absent. Even c minus b 2b is 0. In that way also we can find out. So now let us find out. Let us find out. Comparing constant terms on both sides. So what is the constant term? C minus, that is c minus 2b. But here this side no constant term. not constant terms. Wait. Let me, not constant term. Comparing coefficient of x on both sides. So on comparing coefficient of x on both sides, so what do we get now here? That is c minus 2b equals to 0. We need c value. C equal to 2b. Here b is 3 upon 8. 2 times 3 upon 8. 2 1 ja 2 4 ja. That is 3 upon 4. So therefore c value equals to 3 upon 4. Now the partial fractions we need to write it. See, now here you check it now. This is the a value, correct? You can check your solution. This is a value. So this is b value, 3 upon 8, c value. Now substituting here in this one now. A upon x minus 2 plus bx plus c by x square plus 4. So partial fractions we can write now. So therefore we can write x square plus 1 upon x minus 2 into x square plus 4 equal to, we have like this, a upon x minus 2 plus bx plus c upon x square plus 4. Let us substitute respective here values. Here see, a is equal to 5 by 8. So a is equal to 5 by 8, b is equal to 3 by 8. A is equal to 5 by 8, b is equal to 3 by 8. So now we can write this equals to 5 upon 8 x minus 2 plus this will be 3 upon 8 x, c value is 3 by 4 plus 3 by 4 upon x square plus 4. So further it can be simplified. Okay, how could you simplify? So this equals to, we can write 5 upon 8 times x minus 2 plus, here 8 is the LCM, so you will be getting 8 times x square plus 4. 8 is the LCM for only this one, 3x you will be getting, plus 4 times 2, 2 into 3, 6, 3x plus 6. So these are the partial fractions. I hope you might have understood this one. So we shall proceed to the next problem. This is the question. Okay, note down the question, all of you. Right. Third question. Let us move to the third question now. So now resolve 2x square plus 3x plus 4 upon x minus 1 into x square plus 2 into partial fractions. This is the question. This is the question. So how could you do it? How could we do it? Okay, right now we can write the solution like this. Solution. So let this 2x square plus 3x plus 4 upon x minus 1 times x square plus 2 equals to, for x minus 1 there exists a partial fraction of the form a upon x minus 1 plus x square plus 2 is being a quadratic irreducible quadratic factor, there exists a partial fraction of the form bx plus c upon x square plus 2. Say equation 1. We need to find out a comma b comma c values so that we can find out the partial fractions. This is a method we need to generally adopt. So that implies 2x square plus 3x plus 4 upon x minus 1 times x square plus 2 equals to, here x minus 1 times x square plus 2. Now x minus 1 gets cancelled. We have a times x square plus 2 plus x square plus 2 gets cancelled. We have bx plus c into x minus 1. Right? Am I correct now? You can check this step. So now what shall we do now here? X minus 1 into x square plus 2, x minus 1 into x square plus 2 cancel. So now we can have a times x square plus 2 plus bx plus c multiplied by x minus 1 equals to 2x square plus 3x plus 4. 2x square plus 3x plus 4. You can check the step. So now the linear factor we have x minus 1, so that one substitution can be entertained here. So that means put x is equal to 1. If you put x is equal to 1, what do you get now? A times, here 1 square 1 plus 2 plus bx plus c into x minus 1. 1 minus 1 is 0 equal to 1 square 1, 2 into 1 plus 3 into 1 plus 4. So we can simplify. So that implies 1 plus 2 3, 3 times a 3a plus bx plus c into 0 0, 2 plus 3 plus 4. So this equals to 3a equals to, we have 9. So a equals to 9 upon 3. That will be 3. So a equals to 3. Now a value have been obtained. A is equal to 3. So you can write also here for our reference, a equals to 3. We have the value. A is equal to 3. Right, Tarun Teja? Absolutely correct. So now let us find out right, 1 minute. Let me move to the further step. Next we need to find out right. So now we need to simplify this one. How could you simplify? Ax square plus 2a plus bx into x plus bx square minus bx plus cx minus c equals to 2x square plus 3x plus 4. Clear? It's clear. So now we need to take from ax square plus bx square, take x square common. From minus bx and cx, take x common, and 2a minus c constant. Separate the terms. So we get like this: a plus b times x square, here plus c minus b times x plus 2a minus c equals to 2x square plus 3x plus 4. Comparing coefficient of x square on both sides. Comparing coefficient of x square on both sides. See what do you get now here? A plus b equals to 2. So that is a plus b equals to 2. We know a value. We need to find out b value. B equals to 2 minus a. Transpose a that side. 2 minus 3. We get minus 1. That means b equals to how much? We have minus 1. That means b value obtained. So here write down b equals to minus 1. We know b value. One more value we need to find out. How to find out? You see, you check now here. Here comparing x coefficient. C minus b is equal to 3 you can write. So now comparing coefficient of x on both sides. So very good, very good, very good. So that is on comparison we get c minus b equals to 3. We need to find out c value. C equals to 3 plus b. B equal to negative 1. So 3 minus 1 that is 2. Therefore c equals to 2. Now c value is equal to how much? 2. So now substituting a value here, b value, c value, we get the partial fractions. Okay, let us find out the partial fractions now. Okay, now the partial fractions we can write like this. So therefore 2x square minus 3x plus 4 upon x minus 1 times into x square plus 2. So that we need to write it now. See the partial fractions we can write now. This equals to actually a upon x minus 1 plus bx plus c upon x square plus 2. See a value is 3, so that we can write 3 upon x minus 1. B value is minus 1, so plus of minus x. C is 2 upon x square plus 2. This can be rewritten as 3 upon x minus 1. This is the last step you need to write. 2 minus x you can write. Plus 2 minus x upon x square plus 2. So these are the partial fractions. So these are the partial fractions. See, these are the partial fractions. So you check this one now. These are the required partial fractions. Syed, actually I need the textbook. Actually I have forgotten the textbook somewhere. I didn't find the book, otherwise I have started the book, but I need the book. Could you please I will forward my address through mail. I have your mail with me, so please, if you are able to courier it, you make a courier to, so that I will start as soon as receiving the textbook from you. It's not available with me presently. Better to send a textbook to me. So thank you. So tomorrow we shall continue. Have a nice day. Thank you one and all. Bye. See you.